Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning in. Today we look at how we can use congruent triangles to prove properties of quadrilaterals. And by properties, I mean special features of a given quadrilateral. Now in the notes, I've given you all the special features of quadrilaterals. A quadrilateral is just any four-sided shape. But there are heaps of special types of quadrilaterals like parallelograms, rhombuses, trapeziums, and so on. So in the notes there's definitions of each as well as all the features of each of those. I'm not going to go through these on the video, it'll be quicker for you to read them. But what I am going to do is give you an example of how we might use congruent triangles to prove a property of a quadrilateral. So let's look at just one quick example. So let's look at this example on the screen. So I'm going to use congruent triangles to prove to you that opposite sides of a parallelogram are equal. So by prove, I'm just going to come up with an argument that convinces you. And in maths, the good thing is you can prove something. There is no way that someone can argue against the argument you make. So we're going to start, because we don't have a diagram, let's start by drawing a parallelogram. So the definition and properties of parallelograms are on your sheets. So parallelogram is just a four-sided shape and it has two pairs of parallel sides. So opposite sides are parallel. So that's the definition of it. So I'm going to use that, and I'm going to use congruent triangles to show that opposite sides are equal in length. So this side equals this side and this side equals that side, okay? That's what I'm going to show. I can't use that fact in my proof, however. So at this stage, I don't know whether the sides are equal or not. So I want to use congruent triangles. So somewhere I've got to draw triangles. So what I'm going to do is I'm going to divide this into two triangles. Now what I want to do is show that those two triangles are congruent, because if they are, remember, all corresponding sides and angles will be equal. Okay, so let's have a look at this. I'm going to have to label all the vertices just so things don't get too confusing. So A, B, C, D are the vertices. So my two triangles are triangle ABC and triangle BCD. So when I'm finding congruent triangles, I have to look for equal sides or equal angles. Now because this side here and this side here are parallel, the red line is a transversal. So this angle must be equal to that angle. They form the Z shape, which is alternate angles. So let's write that first. So this angle here, which I'll call angle ABC, is equal to this angle here, which I'll call BCD. And the reason that they're equal is that they are alternate angles of a parallel line. Okay, but remember, I've also got this side and this side being parallel, right? So that means that this angle here, which I'll mark with an X, and this angle here, they must also be equal. And again, that's because of alternate angles. So this angle here, I'll call angle ACB. That is equal to this angle here, which I will call angle CBD. The reason again is alternate, okay? Now, when I'm trying to prove that triangles are congruent, it's good that I know some angles are equal, but I need information about at least one side. I can't show that two triangles are congruent without showing that there's at least one side that's equal. But notice that the transversal, the line in red, this one here, is in both triangles. So it must be the same length in both triangles. And the way we can write this, BC, which is the transversal, is common. It is in both triangles, therefore it's equal in both triangles. So therefore, triangle ABC is congruent to, now we have to line up the vertices. So vertex A actually corresponds to vertex D. So we need to write that first, okay? It's because this first triangle has been reflected. It's been flipped over that red line to get the second triangle. So B corresponds to itself and so does C. So the reason we had two angles and a side. So triangles 1 and 2, ABC and DBC, they are congruent. That means that all sides and all angles will be equal. So because this side here corresponds to this side here, they're corresponding sides of a congruent triangle. So therefore, AC equals BD. So I've just shown that this side is equal to the side on the opposite of the parallelogram. So I've shown one pair of opposite sides is equal. The reason, I'll just abbreviate it, corresponding sides of a congruent triangle. Okay, now because I have congruent triangles, this side corresponds to this side in the congruent triangles, so therefore I've also got that DC is equal to AB, and again the reason is the same, corresponding sides of a congruent triangle. So because I've divided the parallelogram into two congruent triangles, I've been able to show that opposite sides are equal, and I have proved that. Now, I didn't use any numbers or anything. This argument works in any parallelogram. It wouldn't have mattered the size of the parallelogram that I drew. All of this would be the same. The triangles would still be congruent, and corresponding sides of the congruent triangle would still be equal. So I have proved what I wanted to prove, that opposite sides of a parallelogram are equal. And this shows how useful congruent triangles can be. I hope you've enjoyed this video. This has been the luckiest maths teacher in the world. Have a great day.